Thank you for attending our presentation. My name is Risha, and I'm here to present our paper, Soliloquy, Fostering Poetry Comprehension Using an Interactive Think-Aloud Visualization. As text transitioned to digital mediums, researchers have sought ways to support reading comprehension with technology. A common goal is to promote active reading, where learners are critically evaluating what is read. Technologies have tried to recreate paper strategies like highlighting and annotating. Other attempts have sought to more deliberately scaffold certain cognitive processes by having readers construct diagrams as they read. Similarly, technologies have mimicked human tutors by having users self-explain while reading or guiding them through step-based tasks. Certain texts, however, are uniquely difficult for readers, to the point where they may not even know how to begin. Complex texts like poetry, source code, or math equations are dense with extra processes like unraveling the meaning of a metaphor, tracking a program's execution, or interpreting logic from symbols. Such examples like poetry warrant more emphasis on demonstrating the process of reading to learners. So how do we demonstrate to novices what goes on in an expert's mind when they read a poem? Well, to study these processes, researchers have used a technique where participants think aloud while they're reading a poem. Although Think-Aloud protocol is commonly known as a research method, the exercise has also been used by educators in classrooms to help convey the process to learners. However, thinking aloud in a clear manner in front of learners can be a challenging task to perform. Likewise, it's also challenging for learners to follow along without much context. Our goal is to explore how to create a similar demonstration with technology that can improve upon some of these elements and make it accessible remotely for learners. Along these lines, we created Soliloquy, an interface that seeks to visualize the think-aloud of an expert reading poetry. Soliloquy begins by using animations to shade words and show where the reader's eye is focused. When the reader notices something or has an idea, the thought emerges on the screen as a pop-up. Additionally, the word or phrase that triggers this specific thought is highlighted to provide additional context. Soliloquy also allows users to control pace. Anytime a thought occurs, the animation is paused, allowing users to click the thought to resume the animation. Additionally, Soliloquy allows for demonstrating recursive reading patterns where lines are revisited to trigger new ideas. We're also interested in exploring a few design variants. Our first was varying the level of scaffolding provided by Soliloquy. When using demonstrations for teaching purposes, being able to reduce support over time allows learners to transition into solving problems on their own. We explore a low scaffolding variant that includes thoughts which only highlight important elements in a poem. For high scaffolding, thoughts also provide interpretive guidance by clarifying details or discussing how elements could relate to the poem as a whole. Our second variant incorporates multimedia to improve engagement and intuitiveness. Without an actual person in front of them thinking aloud, users may struggle to understand the process Soliloquy is trying to convey. Our variant includes audio of just the thoughts that appear on the screen, and this more closely imitates an in-person think aloud, as text of thoughts become audible with the help of AI. To evaluate Soliloquy and study these variants, we deployed a crowdsourcing study on Mechanical Turk that sought to measure comprehension and cognitive load of participants. Our second study involved Think-Aloud protocol to better observe mental processes of participants as they use different interfaces. Our crowdsourcing study involved randomly assigning participants to one of 5 conditions. The first was high scaffolding, which included detailed thoughts with interpretive guidance as well as verbal audio of the thoughts that appear on screen. Next was the low scaffolding condition, where thoughts only highlighted elements in the poem, as well as accompanying audio for thoughts. We also had high scaffolding and low scaffolding variants with no audio component. Last, we included a static text control that included the same detailed thoughts and corresponding line number positioned to the right of the poem. For assessing comprehension, we used 9 multiple choice questions, 4 of which assess poem comprehension. Another 4 assess the expert reader's mental model. And then we also had 1 validation question, which was used to exclude participants that may have been gaming the task. Almost 1/4 of participants failed to answer the validation question, and the study was also impacted by high attrition rates, where many users return the task without completing it. These factors suggest that there may have been some limitations for engaging participants when using a medium like crowdsourcing. Overall, a total of 254 participants successfully enrolled and completed the experiment. We had the following hypotheses. We expected the soliloquy conditions to outperform the static text conditions. We also thought those receiving high scaffolding would score significantly higher than those with low scaffolding. We also thought that the audio conditions would score higher than those receiving no audio. Surprisingly, we failed to detect a significant difference between soliloquy and static text. The high scaffolding condition did score significantly higher than the low scaffolding as we expected. As for the audio conditions, we failed to detect a significant difference between those receiving audio and those that did not. To better understand the results from our crowdsourcing study, we conducted a second qualitative study using Think-Aloud protocol. For this experiment, we used only high scaffolding soliloquy variant and the static text control to study effects of how interfaces represented information. This time, we used a within subjects approach to better observe individual differences. Every participant interacted with both interfaces, counterbalanced for their order. A total of 13 participants thought aloud while performing the same task and answering assessment questions used in our previous study. One of the more notable findings of our Think-Aloud study was how users varied in their reaction to soliloquy. When using the interface, participants read thoughts as they come up in the poem. For some, this helped them process ideas one at a time, whereas others felt the thoughts interfered with their reading and thinking process. Similarly, users responded differently to the pacing of soliloquy. For some, it helped them slow down and carefully consider each thought. However, a few participants were observed rushing, suggesting some aspect of the interface made them feel hurried. Last, some participants reported appreciating soliloquy guiding their attention. However, other participants enjoyed having the control and freedom of static text. We then tried to connect our findings with results from our previous study. Users that felt a lack of control or felt interrupted would likely have had a higher type of cognitive load known as extraneous load. We found a stronger relationship between this form of cognitive load and the assessment scores for the soliloquy conditions, which might suggest that this load, potentially from individual differences, played a larger role for soliloquy. Likewise, participants feeling a sense of urgency using soliloquy would progress too fast, and those feeling interrupted might progress too slow. We thus analyzed response times and found an ideal range of time where participants had lower extraneous load and scored higher on the assessment, helping confirm the importance of pacing. We have a few takeaways. Our first is differences in reading habits, or how individuals experience certain interface features, could be of critical importance for soliloquy. This means a personalized interface that fits to a user may be necessary. Our study also demonstrated the importance of interpretive details included in the thoughts of the interface. Reducing these details seems to be a suitable way of fading the level of scaffolding so users can practice on their own. Last, although step-by-step approaches are popular in fields like intelligent tutoring, our study suggests they may not be ideal for all domains and users. Thank you for listening to our presentation. Please see our paper for more details or check out the source code of Soliloquy at the following link.